Welcome to Learn Yourself. Today we are going to solve numericals from the chapter number 8 motion, and we are going to solve the final exercise of this chapter. This chapter is under CBSE Standard 9 syllabus. So this is the first numerical of the final exercise, that an athlete completes one round of circular track of diameter 200 meter in 40 seconds. So this athlete here is covering this one round, and that is of diameter 200 meter. This is a track and he covers this in a time of 40 seconds. So this much distance, if he starts from here and he goes like this, then he covers and come back here in 40 seconds. So one round he take in 40 seconds. Now they are asking that what will be the distance covered and displacement at the end of 2 minutes 20 seconds. So at the end of 2 minutes 20 seconds, if he keep on going like this, then after 2 minutes 20 seconds, where he will reach, how much distance he will cover, and how much displacement will be there for him. Now why we have to find out the displacement? Because once he will start from here and coming back at the same position, his displacement will be 0. If the final position and initial position is the same, then the displacement will be 0. So if he takes one full round, then yes, he covers some distance, but his displacement will be 0. So after this much time period, we have to find out that what will be his distance and what will be his displacement. So first we have to find out that what is this total distance. One round's distance is how much? So we have to check this distance, and how to calculate this distance. This is a circle. So once we will calculate the circumference of circle, then we will get the distance. Then in one round, how much distance he will cover. So from there we will start the numerical. That first we will find out the circumference, and then we will check how many rounds he will take in this much time period. So now we know that 40 seconds is there for one round. When he covers one full round, he took 40 seconds. So in 2 minutes 20 seconds, how many rounds he will take, how much distance he will cover, and where will be his displacement. So first let us convert this into second. So 2 minutes is there, so we will convert this into seconds. So we will get 120 seconds, and then we will add this 20 seconds. So it is going to completely 140 seconds. So distance and displacement we have to find for this much time. For this much time we have to find out the distance and displacement. So first we will find out the distance for one track. So the distance covered in one round equals to 2 pi r. Why it is 2 pi r? Because he takes one full round here and he is traveling on the circular path. So once we will find out the circumference of the circle, we will get the distance, and this is the circumference of the circle. So here we will get 2 into 22 by 7, that is the value of pi, into r. Now here they have given the diameter. So from diameter we will get the radius of the circle, that is 200 divided by 2, and we will get 100 meter. So 100 meter is the radius of this circle. They have not given the radius. So they have given the diameter. So from that we have find out the radius. So here we will write 100. R is the radius, and here we have put the radius. So 2 into 100, we will get 200 into 22 by 7 meter will be the distance for one round. That much distance he covered in 40 seconds and in one round. Now we have to find out that if with same speed he will cover, then in 140 seconds how much distance he will cover. So distance cover in 40 seconds equals to 200 into 22 by 7 meter. Why? Because in 40 seconds he takes one round and this much distance. So in 140 seconds, So distance cover in 140 seconds is how much? That we have to find out. So this term in multiplication with this term in divided with this. So we will get here 200 into 22 by 7 into 140. This is unitary method. So we will get here 140 in division with 40 second. So this is 40. Now we can cut this 0 and 0, and this 4 we were writing here 4 5s are 20. So we will get here 5 into 22 by 7 in multiplication with 140. So once we will solve this, we will get 2200 meter. Now this much distance athlete will cover when he travels or when he runs for 140 seconds. Now from this distance we have to find out the displacement. We have to find out the displacement. So this is our first answer. This is our first answer, that in 140 seconds, that in 2 minutes 20 seconds, how much distance he will cover? 2200 meter distance he will cover. Now we have to find out the displacement. So how we can find out the displacement? That one round is of this much distance. Then in this much distance, how many rounds he will take? So similarly we will find out that how many rounds he will take. If he will take 2 rounds, then his displacement will be 0, because at the end of second round he will come here only. His displacement will be 0. If something more than the whole number is there, then only we can calculate the displacement. So here we will find out that 1 round equals to 200 into 22 by 7 meter distance is there. Then we have how much distance? 2200. 2200 meter distance we have. Then how many rounds he will cover? So we can write here 2200 into 1 in division with this. That 200 into 22 by 7. Once we will solve this, we will get here 3.5, and these are the rounds. That this many rounds athlete will take. So after end of 3 round, after end of third round, his displacement will be 0, because he is starting from here and coming back here again. So after third round his displacement is 0. But we have to find out for this half a distance, that 0.5 round. We have to find out for this 0.5 round, because that 0.5 round, that half a circle will give us a displacement. Now to calculate this half round, what can we do is, our radius is 100 meter. Our radius is 100 meter, and how to check the radius? What is a radius? If this is a center of the circle, this is a radius. And if we are talking about a half a circle, if we will multiply 2 with the radius, then we will get a distance of half a circle, that it is 200 meter. Then we will get a distance of half a circle or half a round that athlete takes after third round. After 3.5 round, his displacement will be only half a round, because at the end of the third round his displacement will be 0, because his initial and final position will be 0. So we have to calculate his displacement for only half a round at the last. So that half round, how we will calculate? R equals to 100 into 2. When we will multiply 2 with the radius, we will get the distance for half a circle. We will get the distance for half a circle, and that is 200 meter. Even the diameter is 200 meter. Diameter cut the circle from the half. Diameter cut the circle from the half. So that also we can take here. That also we can take here. The distance of the circle will be 200 meter for half a round. Second question. Joseph jogs from one end A to other end B of a straight 300 meter route. So he jogs from one end A to second and B. So this straight road is of 300 meter. This straight road is of 300 meter. Now, in how much time? 2 minutes 30 seconds. So A to B, he covers in 2 minutes 30 seconds. In that much time, he cover A to B. And what is the distance for A to B? That is 300 meters. So 300 meter he covers in 2 minutes 30 seconds. And then turns around and jogs 100 meter back to point C. So this is point A, this is point B, and then from here he comes back till point C. So this is 100 meter. This is 100 meter. That he comes till point C, and that is 100 meter. In another 1 minute. So from B to C when he comes, he takes 1 minute, and that distance is 100 meter. That distance is 100 meter. And B to C, he covers 100 meter in 1 minute. What are Joseph's average speed and velocities in jogging from A to B and A to C? So for the first patch, A to B, what will be his average speed and velocity, and for complete the track from A to C, when he comes back till the point C. So for that also, what is his average speed and velocity, that we have to find out. So here we are finding out for the A, that from A to B we are finding out. The first one is we are finding out that average speed. So average speed equals to distance divided by time. So for A to B, how much distance is there? 300 meter. So that we are writing here 300 meter. And what will be the time? That 300 meter he covers in 2 minutes and 30 seconds. So 300 meter he covers in 2 minutes 30 seconds. So 2 minutes 30 seconds we have to convert it into seconds. So 2 into 60, we got here 120, and plus 30, so we got here 150 second total time for 300 meters. So that we are writing it here, that second. That much time he take for A to B. So here we will get 150 to 300. So 2 meter per second will be his average speed for A to B patch. Now we have to find out the average velocity. We have to find out the average velocity for A to B patch. Now what about average velocity? Average velocity is displacement divided by time. So what is the displacement here? He goes from A to B. So he covers the distance of 300 meter as well as he covers the displacement. His displacement at the end of this travel is also 300 meter. Here distance and displacement both are same. So here we will get displacement is 300 meter. That end of this travel, when he travels from A to B, he reaches here. So how much will be the displacement? 300 meter. So 300 meter is the displacement, and time taken for this displacement is 150 seconds. So the average velocity, what we got here is 2 meter per second. So when the distance and displacement is the same, so speed and velocity will be same in that case. So this is the first thing, that from A to B patch we got average speed and we got average velocity. Now for the patch of A to C, we have to find out the same average speed and average velocity. Now for the second option, A to C, we have to find out the average speed. Average speed, the formula of that will be same, that distance divided by time. So how much distance he covers? First he go from A to B, so that is 300, and then he comes back from B to C, so that is 100. So distance here is going to be 300 plus 100, so that is total 400, and time taken for that is, this is 2 minute 30 second plus this is 1 minute. So the total time for this travel is 2 minute 30 second and plus. So from A to C, the time taken is total 2 minute 30 second is 150 second. 150 second and plus when he comes from B to C, he take 1 full minute. So that 66 second will be added into that. So total time will be 150 plus 60. So that is going to be 0, then 1 and 2. So that is going to be 210 second. That is going to be complete time. That is 210 second. How 210 second? This time is 2 minute 30 second and into that we have added this time. That this covers in 150 second and this covers in 60 second. So we have added this two time. So that is completely 210 second. That is completely 210 seconds. So here we got 400 divided by 210. So 0 will get cut. Here 40 divided by 21 is there. 1.90 meter per second will be the answer. And this much is the average speed for A to C patch. For A to C patch, this much is the average speed. Now we have to find out the average velocity. Average velocity equals to displacement divided by time. So here how much is the displacement, that we have to see. That Joseph goes from A to B and then he come back here. Then he comes back till point C. So its actual displacement is that we have to calculate it from point A till point C. That we have to calculate it. If this full path is of 300 meter, he already covers 100 meter while coming back, then left is only 200 meter. Left is only 200 meter. So this 200 meter is the displacement. That much he is far from the initial position. That much he is far from the initial position. So that much is the displacement. What is the displacement? How much body moves from the initial position. So at C point he is there. So that much his body moved. So how much far he is from the initial position? 200 meter. So that is going to be the displacement, that 200 meter. And for this, how much time he required? So we have to write total time. That A to B and then B to C. So total time is 210 second. 210 second. So here we will get answer is 0.95 meter per second. And 0.95 meter per second will be the average velocity. And will be the average velocity. So what we have done is, first we have found out the average speed for point A to B, and for the same we have found out the average velocity. And similarly we have find out from A to C the average speed and average velocity. So what is the difference here? We have to check for the displacement and we have to calculate the correct time, that from which point till which point how much time it requires. Third numerical is, Abdul while driving to school computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and average speed was increased and it was 30 km per hour. What is the average speed for Abdul's trip? So now we know that while he is going to school, the speed was 20 km per hour and distance was d. While coming back, his speed was 30 km per hour and distance was d. In both the case, the distance will remain same because he goes from home to school and school to home. So distance will remain same, but here the speed is changing. That while going it was 20 km per hour and while coming back it was 30 km per hour. So time taken for this to and fro journey will be different. So first we will find out the time. That while going how much time he will require and while coming back how much time he will require. So first we will write that while going. So while going we know that what was his speed. So speed equals to distance divide by time. So from this we will find out the time, that while going how much time he will require. So we know that this is 20 equals to d is the distance and divided by t. Now here we will find out the t. T equals to d divided by 20. Why? Because this t 20 will come at the place of t and t will go here. So this is the time for the first trip. This is the time for the first trip. Now while coming back, what will be the time? So same, we will find out that s equals to d by t. We will get here 30 equals to d by t. So the time we will got for the second travel is t equals to d by 30. T equals to d by 30 we will get while he is coming back. Now when we will find out the total time, the total time required for this equals to this travel time and this travel time. So that is d by 20 and d by 30. d by 20 plus d by 30. How we got that? That this is the time while going and this is the time while coming back. So when we will add this time and this time, we will get total time for the journey. So here we will get d by 20 plus d by 30. So we have to take LCM and we will get here 2d plus 3d divided by 60 equals to 5d divided by 60. So here we will get 12. So the total time equals to d by 12. Total time required for the journey is d by 12. This is our total time. So now we have to find out the average speed for his journey. So average speed equals to total distance divided by total time. So what will be the total distance? To and fro it is d. So while going it is d and while coming back it is d. So it is d plus d. Distance are same at both the sides. So d plus d. And total time we got here is d divided by 12. Now this 12 is in denominator. So it will go in numerator. So here d plus d we will get 2d, and then in division the d, and then in multiplication we will get 12. So this d and this d will get cancelled. How we arrange this? D plus d is 2d and d will remain in denominator, and this 12 is in denominator, so it will go in numerator. So it will come in multiplication. Now d and d got cancelled here and we got here 2 into 12. So we will get here 24. 12 into 2 we will get 24. Now this 24 is kilometer per hour. Why? Because our speed here are kilometer per hour. So whatever average speed we will get here is 24 kilometer per hour. So that is the average speed from both of this journey. While going and coming back, the average speed will be 24 kilometer per hour. Fourth numerical is a motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meters per second square for 8 seconds. How far does the boat travel during this time? So we have to find out the distance. Now first they have said that motorboat starting from the rest. Starting from the rest means it was standing, it was at the resting position. So its initial velocity will be 0. Its initial velocity will be 0 because it was at resting position. Now accelerate in a straight line at a constant rate of this. So this is our acceleration. It is accelerating the speed and this is acceleration. See the unit, it is meter per second square. If it was a velocity or a speed, then the unit was meter per second. Here the unit is meter per second square, and here second hint that it says that it accelerates the speed. So this is acceleration, that A equals to 3 meter per second square. This much is the acceleration. for 8.0 second. For 8.0 seconds. So time it requires to accelerate this much is 8 seconds. 8 seconds is the time. How far does the boat travel during this time? So in this time, how far will the boat travel? So how much distance it will cover when it accelerates this much? So in this much time, how far it will go? So we know the equation that distance, that S equals to ut plus 1/2 at square. This is the equation for the distance. U is initial velocity, t is time, half a is acceleration, and t square, again t is a time. So u, we know that it is 0. Initial velocity is 0 because it was at resting position. Then time they have given is 8 plus half into a is 3, and then again t is 8, and that too its square. This term will be 0 because it is in multiplication with 0. So remaining term is half into 3 into 8 square. So we will get here 1/2 into 3 into 8 into 8 because it is in the square. So 2 4s are 8. So we will get here 3 into 8 into 4. So 3 8s are 24 into 4. We will get here 96 meter distance because this we are getting distance. So this is 96 meter distance boat will travel in 8 seconds. Question number 6, and this question is based on the graph. In the question they says that figure 8.11 shows the distance time graph of 3 objects A, B and C. Study the graph and answer the following. So this is the graph which they have given in the textbook. Here the y-axis is showing the distance 4, 8 and 12 kilometer, and this x-axis is showing the time. So here 0.4 hour, 0.8 hour, 1.2 hour, 1.6 hour and 2 hour. So 1 hour is in between here and 2 hour is here. So that is how they have shown the time on x-axis. Now we have to study the graph for these 3 objects travel. Object A, object B and object C. So first let us check for the object A. So for object A, travel starts from here. So here it is 6 kilometer. So this travel is not starting from the 0 kilometer. It is starting from the 6 kilometer. So its journey is starting from 6 kilometer and finishes somewhere here. So if we will extend this line towards the x-axis, then it is showing 2 hours. The time which is showing is 2 hours. That this journey is starting from the 0 hour and it is finishing at 2 hours. If we will extend this line, it will give us 2 hours. Similarly, if we will extend this line towards y-axis, it will give us 12 hours. So object A's journey is from 6 to 12 kilometer. It's starting from 6 kilometer and ending at 12 kilometer. So journey will start from 6 to 12 and it is taking 2 hours time. It is taking this much time. So 2 hours time. So this is for A. Now let us check for B. So B lines, and object B's journey is starting from 0 and it is finishing here. So if we will extend this line towards x-axis, it will give us time. So it is showing that it is coming here somewhere. So this is in between 1.2 hour and 1.6 hour. So this time tells us that it is 1.4 hour. 1.4 hour because it is in between 1.2 and 1.6. So it is 1.4 hour. And at which kilometer it is finishing? Almost at 12 kilometer. So object B's journey is from 0 to 12 kilometer and it is finishing in 1.4 hour. It is finishing in 1.4 hour. Now similarly for the C. So C travel is starting from here somewhere. So here it is 2 kilometer. It is not starting from 0. It is starting from 2 kilometer. 2 kilometer till here. 12 kilometer. 2 kilometer to 12 kilometer. If we will extend it for till y-axis, then it will give us 12 kilometer, and if we will extend it on x-axis, then it will give us the time. and it is showing that this is showing us that it is 1.6 hour. Then it is showing us that 1.6 hour. So 2 to 12 kilometer journey object C is traveling in 1.6 hour. So these are the timings and journey for all the three objects. This is what we got it from the graph. Now we have to answer all these questions. So first question is, which of the three is traveling the fastest? So if we will see here, so B is completing its journey because it is starting from 0 and it is reaching till end point, and that too in 1.4 hour. So the time is lesser than this both A and C. So B is traveling the fastest. So answer here is B. So object B is traveling the fastest. Now, are all the three ever at the same point on the road? That means they are saying that are all three are crossing their path on at any one point. Are all three crossing their path? No. Two objects are crossing their path. That one is here, one is here, and the other one is here. But all three are not crossing at any point. They are not crossing at any point. So the answer is no. They are not. They are not crossing with each other. They all three are not crossing with each other at one point. Two objects are crossing. How far has C travelled when B passes A? That means they are saying that when B passes A, that means when B is crossing A. This is the B and this is A. This line is for B and this line is for A. So they are passing it here. So when they are passing each other, when they are crossing each other, where the C will be? So C line is here. C line is somewhere here. Now once we are taking the point, we have to extend it till the x-axis and we have to extend it till y-axis. Then it will give us kilometer and time. So here we will get the kilometer is 8 kilometer. When we will extend this line, till y-axis, then it will give us 8 kilometers. So when A and B are crossing each other, when they are passing each other, the C will reach till 8 kilometers. So here answer we will get is 8 kilometers. C will reach till 8 kilometers. Then how far has B travelled by the time it passes C? So here both travel line is different. Their both kilometers are different because here B is little bit faster than C. So both kilometers are different, but they are crossing each other over here. So when they both passes each other, the B is reaching at somewhere here. B is reaching at somewhere here. So that is 5 kilometers. So B travel by the time passes C is, B will reaches the 5 kilometer. B will reach at 5 kilometer. So at that time, when B and C are crossing each other, the B has already passed 5 kilometer. Seventh question. A ball is gently dropped from a height of 20 meter. If its velocity increases uniformly at the rate of 10 meter per second square, with what velocity will it strike the ground? And second question, after what time will it strike the ground? So here the ball we are dropping from certain height and we are gently dropping it. We are not forcing it. We are gently just dropping the ball and at the height of 20 meters. So this height is 20 meter. This height is 20 meter. Now what they are saying that its velocity increases uniformly at the rate of this. Now whether this is a velocity or this is a acceleration. So how to check that? First thing, you can check that whether they have said that this is a velocity or they have said that increasing velocity or decreasing velocity. When there is a change in velocity, it is acceleration. So here they have said that velocity increases uniformly at the rate of 10 meter per second square. So this is acceleration because velocity is increasing. So this is acceleration. And second thing, from the unit you can check. that whether this is velocity or acceleration. Velocity's unit is meter per second, and here the unit is meter per second square. So this unit is belong to acceleration. So this is acceleration. So this is the way you can make out whether they have given the velocity or acceleration. And it is very important to find out that whether this is initial velocity, final velocity or acceleration. So first thing is unit, or you can check here whether they have said that increasing, decreasing at uniform rate or something like that is there, then it is acceleration. And simply velocity, then it is either initial velocity or final velocity. So here this is acceleration. So with 10 meter per second square, it is falling down. So what they are asking, that with which velocity it will strike the ground, with which velocity it will strike the ground here. So final velocity we have to find out, and initial velocity. When we are dropping it from the hand, the initial velocity, we are not giving the force, we are not applying the force, we are just dropping it. So its initial velocity will be 0. We are not giving any force, so we are just dropping it. So its initial velocity will be 0, and final velocity, with which velocity it will strike the ground. So that final velocity we have to find out. And what they are saying, that after what time it will strike the ground. So if with all this velocity, with this much distance, with this acceleration, if it will strike, then how much time it will require? Then how much time it will require to reach at this distance? They have already given us the distance, that 20 meter height. 20 meter height means this is the distance. This ball is traveling 20 meter when we are dropping it from the hand. So let us note down all these things. So initial velocity is 0 meter per second. Final velocity we have to find out that what it is. Time we have to find out. Then acceleration, they have given that 10 meter per second square, and they have given the distance. That height they have given, that is our distance, that it is 20 meter. Now we will find out the final velocity. From all this data we have to find out the final velocity. So we have the equation that 2as equals to v square minus u square. Now we know a, s and u. We have to find out v. So let us rearrange this equation. So v square equals to, we will get 2as plus u square. Now equals to 2 into 10. 10 is our acceleration, s is 20. So here we will get 20, and plus u. U is 0. So 0 square. So here we will get 2 into 10. So it is 20. 20 into 20. So we will get here 400 plus 0. So it is going to be 400. Now this is v square. This is v square. So both the side, if we will take square root, we will get v equals to 20. V equals to 20 we will get. Now v is our final velocity. So this is meter per second. This is meter per second. This 20 is meter per second. And here this 20 is going to be positive because here velocity is increasing and it is in the direction of falling. Where it is falling, it is in the same direction. So this is going to be positive. This final velocity is going to be positive. Now what we have to find out is t. We have final velocity, initial velocity, distance, acceleration, everything we have. We have to find out the t. So the equation we will use is s equals to u plus at. So now as we know that it is 20 meter, so here I will write 20 equals to u. U is 0, it is initial velocity, plus a. A we know that it is 10 and t we have to find out. T we have to find out. Now 20 equals to 10t. So now 10 we are taking over this side. So it is in multiplication, it will go in denominator. So 20 divided by 10 equals to t. So here we will get 2. So t equals to 2 second time. T equals to 2 second time. So if with this much acceleration the ball we are gently dropping from 20 meter height, it will have 20 meter per second final velocity and it will take 2 seconds to strike the ground. It will take 2 seconds to touch the ground. Question number 9 says that state which of the following situation are possible and give example for each of this. So we have to identify this example and we have to check whether this situation are possible or not, and if yes, then we have to give one example for that. So A is an object with a constant acceleration. The acceleration is constant but with zero velocity. So continuously that object is traveling in the acceleration but it has a zero velocity. So when this will happen? When we are throwing a stone upward in upward direction. Stone or ball, anything, when we are throwing it upward. We have seen this in the numerical, that when we are throwing it upward, what will happen? It starts from here, we are throwing with certain velocity, so it has some initial velocity but its final velocity will be zero, because at one point it will stop and it will come back. So when it comes back, it's fine, for a fraction of second its final velocity will be zero, but it is in continuous acceleration. It is in continuous acceleration. So in this case it has an acceleration but its final velocity will be 0. Then second, an object moving with an acceleration. It has acceleration but with uniform speed. So when any object has acceleration but it has also a uniform speed. Now what is the acceleration? Acceleration is changing of velocity and it is along with the direction. So it has a uniform speed but it has acceleration also. So when any athlete is moving on a circular track, so at each and every point his direction will change. So he has acceleration but his speed is uniform. He is moving with a uniform speed. Or we are tying a stone or a ball at the end of a rope and then we are giving a circular motion to that. So in that case also, in each and every point, at each and every point its direction will change. It has acceleration and it is moving with a uniform speed. So either of this example will suitable for this situation, that it has acceleration also and it is moving with uniform speed. Question number C. An object moving in a certain direction with an acceleration. So it has acceleration and that acceleration is in the perpendicular direction. So it is moving with certain acceleration but it is in the perpendicular direction. So that happens in circular motion. In uniform circular motion, when body travels in certain direction, we know that in uniform circular motion at each and every point the direction will change. The direction of athlete, direction of the object will change when they are moving on circular path. So the direction of the body will be always in perpendicular to its movement. So here in circular, uniform circular motion, this can happen, that acceleration in the perpendicular direction. Their movement is circular, so their acceleration will be perpendicular to that movement. So this is the case when in uniform circular motion these things will happen. That object is moving in a certain direction, that it is moving in this direction and acceleration will be perpendicular at each and every point. If here also the direction is there, then its acceleration will be perpendicular. Acceleration will be perpendicular to that movement. 10th question. An artificial satellite is moving in a circular orbit of radius 42,250 km. Calculate its speed if it takes 24 hours to revolve around the earth. So we have to find out its speed. And what data they have given, that orbit of radius. So it is in the circular motion. It is in the circular motion, and what they have given is radius. They have given the radius, and radius we have is 42,250 kilometer radius they have given. And we have to find out the speed, that what will be the speed if it takes 24 hours. So time they have given is 24 hours. Now here the distance they have given in the kilometer and speed they have given in the hour. So we can find out the speed in kilometer per hour. And they have not specified here that find out the speed in meter per second or kilometer per hour. So we can find out the speed in kilometer per hour. So we do not need to convert anything over here. We will use them as it is. First thing, we have to find out the distance, because we need to find out distance to find out the speed. So how to find out the distance? Because this path is circular. Whenever the path is circular, we are finding out distance with the circumference of the circle, and that is through 2 pi r. So let us find out the distance with 2 pi r formula. So 2 into 22 by 7, and then we will multiply the radius. Radius is this, that is 42,250. When we will solve this, we will get here 2,65,330 kilometer. So this much will be the distance. This will be the distance when the satellite is moving around this circular orbit. So this much distance it is covering in this much time. In 24 hours it is covering this much distance. Now we will find out the speed. That speed equals to distance divided by time. So distance, we know that distance is 2,65,330 kilometer, and time what they have given is 24 hours. So when we will divide this two, that this distance and this time, we will get speed in kilometer per hour, and that is 11,055.41 kilometer per hour. So that is going to be the speed of satellite. This speed we got it from distance divided by time, and distance we got it from here, that they have given us a radius and this is a circular path. So we got this distance from 2 pi r, because every time whenever it is a circular motion, we have to take the circumference of the circle. To find out the distance, we have to take circumference of the circle, and that is how we found out the distance here.